All right, so first thing before I go into the welders, I'm gonna go over safety. One, you wanna have your arms covered. So you wear, I'm gonna put it on when I get closer to it, but a long sleeve jacket. There's some flame retardant cotton jackets, but you know, you don't wanna have something that's going to burn or melt readily. Denim works pretty well. Leather works well. Leather welding jacket can work pretty well. Will work very well. I just have an apron on because it keeps me from burning. Lots of little holes in my pants and stuff. You want your clothing that you're wearing to be relatively non-flammable. You want to have solid shoes on that cover your entire foot. It's better. Leather would be better, or something that won't burn or melt. Nylon tends to melt, and sparks can touch it. So you want your skin to be all covered, and you also want to have your safety glasses on with side shields. Also, a welding helmet. There's some of them over there on the wall. This is an auto darkening helmet. It has about a shade 2.5, and then it goes to when there's a spark, the arc gets struck, it changes to goes to about a 10 or more, depending on what you had it set for. Oh, here we go. This one's right now it's set on 10. Some of them have different types of setups. So a 9 is pretty low. Generally 10 is a good ballpark number to kind of shoot for a shade. You don't really want it much lower than 10. Your eyes will start to get damaged. There's a chart on the door over here that goes over the different shades that you could utilize for the different amount of amperage that you're working with and different types of welders. But generally 10, the old time test is if you're welding and you notice that, you know, when you close your eyes afterwards, you see it's like you accidentally stared at the sun, and you close your eyes and you see that ball, that orange ball, you see that light in there. When your eyes are closed, you need a darker shade. So if you're having problems, you can damage your eyes permanently. So make sure to have the shaded helmet in the helmet. This also protects your skin. Sometimes what I have here, I would button up or have the jacket on, because I'll end up with a arc burn, like a sunburn from that. So we already have enough sun in Arizona, so we don't need to give ourselves any more sunburns. So that will have, you can adjust this back here, and you have to push in. See if we can get that. Push in on that and turn it. Don't try to turn it without pushing it in. It's just kind of stuck. So you can adjust that. You can also adjust this top part too by popping this out and adjusting it so it fits your head comfortably. Okay, maybe not comfortable, but reasonably well. And you're also going to have a pair of gloves on. We have the thinner gloves. Realize the thinner gloves will get hot. If you hold on something with a glove and you feel the heat coming to it, first off, put the hot thing down, and then take the glove off, because it can absorb some of that heat, and you can continue to burn your hand in the hot glove. So these are thinner ones that work well with MIG welding and some other processes we use. We also have, if you want some more protection, some thicker ones. Just that sometimes these can be harder to work with some of the equipment, but they can definitely they're more protective. They're thicker, but that being said, you still need to make sure, if you pick up something hot and you feel it through the glove, put the hot thing down and take the glove off, because you can continue to burn your hand, or get away from whatever. If you're in a situation, get away carefully from that situation. Also think about that every piece of, stop rocking back and forth. Everything in the shop, any piece of metal you see lying around, assume that it's hot. Do not just go and pick it up. Test, put your hand above it so you can feel like if there's any heat to it. So make sure that you don't try not to burn yourself. Small burns and cuts are to be expected, but we keep it to a minimum. So electric welding, I'm going to basically what both the MIG and stick welding are, use electricity to create an arc where you get the heat to melt the metal. You can think about that in both of those cases. When you were a child, when you were a youngster, and you were in the living room, and no one's around, so you grabbed the cord off of one of the lamps, you yanked it out of there, and then you chewed on the rubber coating on there. Didn't taste that. You decided that was, thought it was chocolate. Anyway, licorice. Chewed on it, you realize there's some copper wires in there, and then you peel it apart, you have two wires. So then if you took that, when you're doing that, when you're a kid, you plugged it back in, you brought those back together again, you got a big bang. Flash of a light, and they'll probably pop the breaker and the lights went out and everything. What happened there was essentially what's happening with these machines as well, except this is much more controlled. Talking about it. Here we go. We have two little stick welders here. Relatively inexpensive little stick welders, which I'll go over momentarily. All right, so we're a little closer up to this guy here. And it's got a couple of different cables on it. One is the power cord, tangled up. And this can be either 220 or 110, and we're using it with 110. In momentarily. And then the other cables are the electrode holder. Which is this guy here. And what that is used with is an electrode. And this is a 6013 electrode, has a bare end on it. This right here. And that gets clamped inside these grooves. Everything's really off right now, so you don't need to worry about, so you can put it in a different type of groove to get positions. I kind of tend to like that kind of straightforward one. So that's that. The other thing, and I usually set that on a brick or a block, not directly on the table that I'm going to ground. The other one is the ground cable. Okay, so that's this guy here. So you clamp that directly to the metal, to the tape, directly to the metal you're going to be working with, or to the table that you're working on, so that it's connected. Now, if you put some bricks down and put them between the ground and the stick, you won't have any connection. So you'll get, you won't get a spark. You will, this doesn't have a pilot arc. Neither the MIG or the stick welder have pilot arcs, so if you don't have it grounded, you won't get a strike, an arc. So this is our MIG stick welder. And it has, basically it's set to stick, has a power switch on the back. Right there. And then it has a digital readout right here. Let me just plug that. So when you turn this on, when I flip this switch, the switch in the back, it starts up, and we get some numbers here. Right now it's got 70 on it. If I turn this down, the numbers go down. Turn it up, they go up. So we typically have some 6013 electrodes that are about 3/32 of an inch diameter, and those run from 40 to 90 amps. So you can kind of start at 70 and see where it goes. If you're melting holes through, turn it down. If you're having trouble striking the arc, sometimes it can help to turn it up a little bit. But remember, you're trying to create enough heat to melt the metals together, not just melt the electrode. All right? So generally, also our stick welders are set up, these two little stick welders are set up with the electrode positive and the ground negative. And generally we're using these with the heavier 1/8 inch steel that we have kicking around. The thinner sheet metal, the 18 gauge and the 22 gauge go in with the MIG welders.